Hello, everybody. So what we want to do now is we want to talk about 8.3. And so 8.3, we've got a couple of theorems to deal with how I basically multiply and how I can divide complex numbers that if they're in trigonometric form. Okay, so this first theorem is called the product theorem. And so that's saying if I have something like R1 times cosine of theta 1 plus I sine of theta 1, and I multiply that by R2 cosine of theta 2 plus I sine of theta 2, what do I get as a result? Okay, so I'm not going to prove what I'm about to write down. If you are interested in how to get it, just think about kind of distributing it out using some of these sum and sum identities for sine and cosine that we had, and I think you'll see where it comes from. So I would have R1 times R2, and then with the cosine, what I do is add the arguments. So I add the theta 1 and theta 2. So I have R1 times R2 cosine of theta 1 plus theta 2, and then plus I, and then times the sine of theta 1 plus theta 2. And that's a pretty simple formula. Remember when the numbers were in rectangular form, I had to distribute it out and simplify all that, and I didn't get a lot of understanding what was going on. Here we're saying if I have one complex number with an angle, say theta 1, and maybe another one with an angle theta 2, and if I multiply those together, I get an angle with, say, theta 1 plus theta 2, and then scaled up to whatever the product of these two moduli are. So, I mean, don't really need to think about it pictorially, but something's going on with multiplying of the moduluses of the complex numbers and the adding of their arguments when I'm looking at the product. And I wouldn't have really have seen that as well if I had kept the number in rectangular form. But what we want to do is just use this formula that we have to simplify some of these. So let me give you an example. So let's say we have number 3. And this works whether our angles are in degrees or radians, either one. Let's say we had 60 degrees, I sine of 60 degrees, and then times, this one's 2 cosine of 90 degrees plus I sine of 90 degrees. And they ask us to write that in a rectangular form. Okay, so I would first use that product formula. So 3 times 2 is 6. So multiply these two. And then I would have cosine of 60 plus 90 degrees, and plus I times the sine of 60 plus 90 degrees. And this is going to be 6 times the cosine of 150 plus I times the sine of 150. And then we're almost there, and then I just want to continue to write that in rectangular form. So what's the cosine of 150 degrees? From the unit circle, you can probably see that is negative root 3 over 2. And then I have sine of 150 degrees would be, let's see, 1/2, right? Then I would just multiply. So if I distribute 6 divided by 2 is 3, so what I really have is a negative 3 root 3, and then 6 times a half is 3. So I have negative 3 root 3 plus 3i. And that would be the product of those two complex numbers in rectangular form. Okay, let's take a look at another one. Let's do one where I've got radians. Well, let's say we have 4 cosine of, say, pi over 2 plus I sine of pi over 2. And I'm multiplying that times 2 cosine of pi over 3 plus I sine of pi over 3. So maybe I'm dealing one with like that, where I have radians. So same idea, it'd be 4 times 2 is 8. This would be times cosine of pi over 2 plus pi over 3. And then plus I times the sine of pi over 2 plus pi over 3. And then you would just have to work out what that pi over 2 plus pi over 3 is. So multiply by 3 over 3, by 2 over 2. 3 pi plus 2 pi is 5 pi over 6. So this is really 8 cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. Cosine of 5 pi over 6 is actually negative root 3 over 2. And sine of 5 pi over 6 is, again, a half. So actually kind of picked the same angle unwittingly there. 90 and 60 in radians, and didn't think about it, but that's okay. If I distribute the 8, that's going to be 8 divided by 2 is negative 4 root 3, and then 8 times a half is 4. So I get this. So it would work in radians as well. Okay, another theorem. Quotient. The quotient theorem. So this says when I have complex numbers in polar form, like if I had R1 cosine of, say, theta 1 plus I sine theta 1, and I divide that by R2 cosine of theta 2 plus I sine theta 2. So what I get if I divide complex numbers, so here, all I would do is just do R1 divided by R2, and with my angles, I actually subtract. A little bit harder to see, but if you want to multiply by the conjugate of this complex number down here, and then you've got some difference identities of sum and sine and cosine that you can look at. But you get this result, R1 over R2, and then times the cosine of theta 1 minus theta 2. Order matters there. And then plus I times the sine of theta 1 minus theta 2 is our formula for this guy. Okay, so what I want to do is I want to do some problems with this one. So let's take a look at this. This is 14. So I've got 24 cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. And then we're dividing that by this complex number 2 cosine of pi over 6 plus I times the sine of pi over 6. And I want to write that in rectangular form. Find rectangular form. Getting it. Okay, so I use that quotient theorem. So here I would do 24, divide that by 2, cosine of the 5 pi over 6, this is the first angle, minus pi over 6, and then plus I times the sine of 5 pi over 6 minus pi over 6. And we need to think about what this is. Okay, so this guy, 5 pi over 6 minus pi over 6 is 4 pi over 6. That's just 2 pi over 3, so this is really 12 cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. What's the cosine of 2 pi over 3? So that would actually be negative a half, right? And sine of 2 pi over 3, that would be root 3 over 2. And then distribute the 12. So 12 times this would be negative 6. 12 times root 3 over 2, 12 divided by 2 is 6, so I'd have I times 6 root 3, 6I root 3, if you want to write it like that. And that would be it. So now it's in rectangular form, and that would be all we would need to do there. Okay, that's pretty good for 8.3. That's about all that I wanted to do out of 8.3. So just doing a couple with the product formula and the quotient formula with the polar form.